Hi, my name is James Vogel of the Bioprocess Institute, and this is Between Two Ferrules. Today's guest is Andrew Lamore of Bürkert USA Corporation. I've worked with Andrew for many years in both his capacity at Bürkert, and he is also in the ASME BPE. Currently, he is the vice chair of the ASME BPE, and we will discuss Bürkert's offerings, which include some pretty novel technology on valve manufacturing, as well as their FLOWave acoustic sensor flow meter. So please join me in welcoming Andrew Lamore to Between Two Ferrules. Welcome, Andrew.
Oh, thank you very much, Brad.
Glad to have you here at the Bioprocess Institute.
Always a pleasure.
Yep. It's been a while since you've been here.
It has. Wow, you've been busy.
Yes, we have.
It's almost like this market has taken off and you're learning all kinds of things.
We are. We've probably this year crossed the mark where we're doing more single-use testing than multi-use.
Makes sense.
But we're here to talk about Bürkert and kind of some of the multi-use things that you've been doing there. And there's been some great stuff, so I'd like to get into that. So why don't you share with us maybe some of the things you're doing on re-engineering things with the valves and manufacturing methods and some things where you're bringing some value.
Yeah, for sure. And I think that's the important part is what's the value, what's the reason for using this stuff. No one really cares what a valve is, it's what it does.
Well, we use them a lot. I
We
mean,
do.
you know, there's many in most plants that we have.
Yep. About 10 years ago, we decided to invest heavily in a project we call Sigma. So it's a project name, a technology project. And what this technology project stipulated was that you can be more competitive, you can be smarter if you make a better mousetrap. So it's not necessarily making it cheaper, but making it better. So we firmly believe that technology is kind of what's going to separate us in the market, what's going to drive the industry forward as a whole, not just ourselves. I mean, that's one thing. So we took information from folks like me throughout the world. There's about 40 of me, one in each region that we have operations. And we said, okay, what do you like and what do you not like about diaphragm valves? And so once we collected all this kind of feedback, we got information like, hey, I want an individual serial number right on the back.
Right on the body.
Right on the body. I want to see this degrees of inclination right on the body. And then from some of the mechanical guys, like the fitters, the pipe fitters and whatnot, they said, I want a flat surface, so I don't need some kind of weirdo tool. I don't have this round thing. So we decided to just mill it flat so that you could easily put a level on it and then get the angle of inclination.
Okay.
Now we still have like the hash marks and all that stuff that's required per BPE guidelines, but even something as simple as that, and you know these same mechanical guys, they said, why do I have to take apart a diaphragm valve? Because sometimes I gall the bolt, sometimes I mess something up, I slip, whatever. I don't have air available on the site yet because it's construction and it's muddy boots and all that stuff. So in those cases, we said, well, why don't we just package it as body, diaphragm, bolts, actuator? And that saves you 20 minutes per valve.
Of taking them apart or whatever and messing up the diaphragm that was already installed or something that way. And we know with our testing, we get most of them here already assembled, and we take them apart and usually have to put in new diaphragms for that. So that makes a lot of sense.
Yeah.
That makes a lot of sense.
The other thing we said at the time was, okay, the diaphragm valve itself was invented, well, really Roman times, but it was pushed in the market, in the biopharm market in the 80s, and it hasn't really changed much since then. And we said, it's the only valve that people don't size. And we said, well, why is that? Why is that assumed? And why aren't there sizing tools available? So people can size them. Because if you size them, maybe you can shrink the footprint of the plant or the unit operation to make it more sustainable. It has less thermal mass, it takes less time, it occupies less space. And so we said, okay, that's what we're going to do. So what you'll find is on ours, to give an example, our 2-inch will flow as much as an industry average 2.5 inch.
Okay.
So if you can shrink on a plant, if everything's 2.5 inch and shrink it all 1/2 inch, you might get an extra suite in that facility. And we've done that.
Okay.
And that's using data and science to actually build a more sustainable facility.
So just to be clear, when you say size, you're talking about more the CV and the flow capability of it, not the tube size. The tube size would be 1 inch, 2 inch like we have in the BPE.
Exactly.
But then the available flow characteristics that can allow more flow.
Absolutely, 100%. And it's backed up by in-house testing and also using advanced CFDs and this sort of thing. So yeah, it's really interesting that we've been able to do this with like the machine valves.
Okay.
Now, we took this same project and we're going to turn it on its head a little bit. So this is where things get a little interesting. This is the same diameter valve, you know, it's just got a tri-clamp on it.
1 inch with a tri-clamp, 1 inch tube weld, yeah?
Yep, no big deal. You'll notice some similarities. It has some markings on it, individual serial number, all that good stuff, angle of inclination. But this is a hydroform valve. So what we do is we take a piece of tubing and at pressure of 3,000 bar, we form that Sigma weir, as we call it, the advanced weir.
And that's the same essential weir that's inside this valve.
It is. But remember I talked about the delta? So we said this product itself could be made more cost effectively because some people don't care. They've got a 1 inch line. It's going to be a 1 inch line. They're not going to resize. That's too much work. That's too much investment. So we said, okay, well, you just need the flow of an average industry 1 inch size. So why don't we downsize the weir by 1? So now we'll give you average industry flow, but a 1 inch line, hydroform valve body, developed in conjunction with the folks at Porsche in Stuttgart.
Wow.
So why don't we do that to make it more cost effective? Because we could offshore this somewhere like a offshore production and reduce costs for a period of time. Then the world catches up.
The
right?
weight has to be a lot different too. So even with the Ferrules, this is much lighter.
Absolutely.
Lighter one.
And,
Yep.
and the only thing that touches the process is the tube wall itself. This is actually the tube wall. So it's stress relieved, it's annealed. The process itself, as we're forming the weir, there's some Cadbury secret to it, to use a Canadian saying, but there's a method to it. And this allows us to do a hydroformed valve that would connect to a hydroformed elbow, a hydroformed T, have all the physical characteristics and testing to support that. So stress relief and impact resistance and all this sort of stuff. But it's a better mousetrap.
Okay.
And so for a more sustainable facility, we can either downsize your process or we can give you a less costly valve that also has pretty cool thermal parameters.
Nice.
Yeah,
Nice.
I think so.
So have you seen your customers, have they been asking, you know, do some have a preference for one or the other, or are able to mix and match and place them in where it needs to go?
Absolutely.
All right, excellent.
So basically the folks that are trying to enter the market, the more less tenured folks, they're more interested in new technology because to them, they don't have an existing standard. They're not worried about they have to rewrite something. And they're open to logic, like you're going to weld this tube-based valve to tube so it doesn't have to be forged material. You know what I mean? Like sometimes you get caught in that spec trap.
Yep.
So those folks, we've seen a lot of availability, a lot of openness to these kind of conversations.
Okay, very nice.
Yeah.
Very nice. So what about multiport valves, or what are you doing with some of those things? And stuff?
That's cool. So check this out. So we also, as part of this project, we took our old Robelux design. So this is the multi-weir design. You remember these from back in the day?
Yeah.
We bought this from GE back in like the late 80s, early 90s. And we were able to now integrate this into...
The same basic footprint.
Yes. So we got some increased KVs here, CVs, KVs, but we were also able to integrate this into blocks. So this is why we bought the technology. Because what if we could do this on a block and bleed? What if we could go back to back to back to back to back? And actually the biggest problem we have on this design is getting enough space to be able to put on tri-clamps or to weld. It's fascinating. So we basically re-engineered this technology. We made the weirs a little softer. We increased the cycle life as a result. You did some of that testing for us. Really, really clever integration of this technology.
Okay.
And being able to use this along with this into some cool batching applications is slick.
So things like our continuous processes, buffer generation with concentrates and so on, this has a great application. Chromatography.
Big time chromatography.
Okay.
So you imagine like the UFO, I always call them the UFO blocks for the chrome blocks. If you take that and shrink it to the size of your fist, the holdup volume goes to nothing. But then you can also apply that to like an outlet block. So you put these together in a chain and then you go maybe back to back. So you have a chain of these and then you go back to back on them. The holdup volume is unbelievable.
And so you could have in that small space 12 inputs or whatever, and then able to do the mixing based on what your controller says or what that is.
100%.
Wow.
Yeah.
Wow.
Cool.
I think the other side of this, I think as we get more miniaturization for things like cellular therapies and all that, this type of design is going to be there. We may have to modify what we have with a diaphragm or whatever, but able to do this in the compact arrangement because we don't have that much volume to play with.
Exactly.
And so the more we can get efficient, God, the better it's going to be.
Absolutely. So wherever the product has an inherent value, where it's worth some money, whether that's time or product itself, but it could even be a product that's, maybe it's got inherent tendencies. I'm going to give you a really low-tech example. Cocoa Puffs. You ever have a big bowl of Cocoa Puffs before, or like Fruity Pebbles, like that really sugary saccharin type cereals? They use this technology for the ink.
Okay.
And just because the ink inherently clogs, and so because it's got a much smaller footprint, it can heat up and cool down much more quickly. The whole skid needs to be small. So from like 5-cent Fruit Pebbles to like a biotherapeutic that's $100,000 an ounce. It can be used in either application.
Well, the process doesn't care. It just needs to be treated right.
Exactly.
So, and you're coming up with some great things, as we say here all the time. Process is king. So we definitely love that. I think also this has a little bit of a tie into sustainability, right?
Absolutely.
You know, when you're able to put this in, so those designers are able to maybe have this satisfy some of their sustainability requirements that they have with less footprint, higher flows,
heat up and cool down times. You hit it bang on. And even as simple as this one, because you're changing 2 weirs, it's a 2-to-1 weir. You're changing 1 diaphragm
for 2.
Exactly. And so you start to do the maths on that. So not only is it more sustainable on the CAFEX side, but also on the OPEX side. And we're starting to see customers basically putting their money where their mouth is.
No, it's coming. It's definitely here. I just taught a course on sustainability last week, and we had more and more people starting to understand and see what's going on.
Which is great, because you see it a lot in Europe, but over here we're still resource rich. We just kind of like set it to the side, but we're actually seeing people put their money where their mouth is.
If you look at almost every corporate statement, Wall Street's already there. It's just how we can get it from the floor up to the people that are reporting to Wall Street. But almost every corporation has a sustainability thing. More importantly, they're getting chief sustainability officers now in there. And the engineers are going to have to talk their talk with ESG and other things to get that to happen. Excellent.
It's exciting, isn't it?
It is. It is. What about instrumentation? Bürkert also does instrumentation. So what do you have some things going along that?
No, this is pretty cool. So this is our FLOWave. You've seen this. You've done some testing on this FLOWave flow transmitter. So this is a technology we purchased 10 years ago. It's been in the market about 10 years. And it uses ultrasonic waves to sense the flow. This is nothing new. So it's like a multi-phase ultrasonic, but it's called surface acoustic wave. It's different, but not.
And they're very compact, I think, compared to some of the competitors and what you have there.
And it's crazy lightweight. Like you can see, like this is a functioning unit. This is right off your test bench. You did some testing for us. And it's designed in that way. This is a no-brainer for things like Wi-Fi. It's an absolute no-brainer. It's tried, it's proven, it's tested technology. We've got about 4,000, 5,000 units in the field, depending where you look at it. So it's not something weird or new or strange. But what's really cool is we've taken this flow meter, and I'm going to hold it upside down because it's okay. You can do it upside down if you want. And we've integrated that into a drop, a zero static T. So imagine you have a standard U-bend, and then you have a leg coming off the side.
We'll show maybe a drawing that we can, that will have the slide that you can see it.
Which is pretty clever. And so this goes into a zero static T area for batching. So now you don't need this complex thing. You don't need an area that could maybe have a dead leg or something like this. It's all integrated into the point of use. So being able to develop that, I think, is quite clever.
So does Bürkert weld this up together, or is that the skid manufacturer or somebody who does that combination?
Dealer's choice.
Okay, so you can provide that service for people with whatever the U-bend or whatever kind of as a module, and then they would just weld that in place.
100%, yes.
Okay, very nice.
Yeah, everything's becoming more of a module because folks, a component is interesting, but some folks kind of want, a module, like a steam set, those basic steam sets. So that I think is cool. The other thing we've been busy on is, it's a bit of a mind shift, but a product doesn't have to be a widget. It doesn't have to be, this flow meter. It can also be the software. Because let's face it, we talked about AI last night over dinner. Like this could be so much more complex. And AI is going to have some implications. And the data is almost more important than the thing itself. So this is where we've been really busy lately, is developing these software tools. So things like contextual displays, device description files for Delta V, or also using the add-on instructions, add-on profiles for Rockwell environments, or then using the Siemens, the TIA portal, developing the software tools for this already developed product. Because the integration and the use of this thing could be more important. It could take more time, right?
Well, we were talking this morning. I was teaching the process control course at the university, and you know, if you're a new engineer coming into it, you'd much rather have it integrated into your platform, Delta V or Rockwell or whatever, than to have to know for each instrument to dive into it on your own and to see where that goes and how that brings in.
Yeah, and I mean, to us, it's chocolate, vanilla, strawberry. You know, what kind of ice cream do you want? We've got the engineering personnel to support it, and that's the big difference, is having the people that know automation, that speak automation first. You know, I'm a big Sparky. I'm an automation head. I can't get away from that. And this is just my DNA, but being able to speak the language in the language is really, really important.
Yep, absolutely, absolutely. Well, I mean, these are great product offerings from Bürkert. You'll have the link to go to Bürkert and to, you know, if you have any other questions, send it to us and we'll get it to Andrew and make sure we can help you out with that.
Yeah.
Let's shift.